Welcome back. In this video, we're beginning our look at generating machine learning models with ChatGPT. We've given ChatGPT a data set, and you can copy and paste any table that you'd like to work with. And you can give it to your agent. Next, we can ask our agent what kind of machine learning you can do on your data. You can go to your agent and ask, what kinds of machine learning can I do on this data? Now, in our case, the agent already has the data. You could also just paste it in, or just say the features that you have, which are the column names. Here, ChatGPT is generating a bunch of ideas. For example, fraud detection, anomaly detection, customer segmentation, predictive analytics, recommendation systems, credit risk assessment. All right, let's give some examples of models. I need some examples of models like linear regression that I could do. This will give us some more specific projects. So here we're going to get some more specific model types that are suggested for this project. So we can go back to the top here. We can see the simplest one is linear regression, which we can use to understand how different factors influence transaction amounts. Another example is logistic regression. We can do predictions such as whether a transaction is fraudulent or not fraudulent. Another example is decision trees, where we can get insights into factors driving credit card transactions, because in our case we're using a credit card data set, and can be used for fraud detection, customer segmentation, or predicting transaction amounts. Another example is random forest, an ensemble technique for fraud detection, credit risk assessment, or customer segmentation. Another example is support vector machines and gradient boosting. All right, let's try one of these examples coming up. In this video, we're going to build our first model, which will be a linear regression model for our data set with ChatGPT. Go to your agent and let's ask it to write Python code for a linear regression model on this data set, which is our credit card data set. Then we'll get an example of some Python code. Now you can use this Python code in Power BI with minor modifications. We can also test it out in Jupyter Notebook, which is an online Python editor, at colab.research.google.com. All you need is a Google account to try it out, and you'll have to upload your Excel file of your data into the files every time you open the project. You can also find this Excel file in the source files of this section. Here in our code, we're going to be using some libraries, and these are actually pre-installed into Colab. Then we're going to be loading our data set from the Excel file and using the fiscal year and the transaction amount as our features, and using the transaction date as our predictor. We're going to be predicting the transaction date. We're going to be using linear regression to do the job, which is a type of machine learning model inspired from statistics. It's like a best fit line. We're then going to create a scatter plot comparing the actual data versus the machine learning model's prediction. We can run the code cell to execute all this code. If you have any error messages, they will appear down here, such as overflow error in this case. Okay, let's see, where did that occur? Looks like it occurred when we were converting date times. Okay, so we are reading our data with our data set. Now, before we pass the data to our model, we must make sure it's all been converted to a numerical format, this X and Y data. And reason being that we need to give our model numerical data. It does not work with any other type. So let's go back to ChatGPT and say that we must convert all the features used and target value to a numerical type. Otherwise, you will get error messages. One technique to achieve that result is one-hot encoding. So for example, here we're using an encoder on our X data. We would also need encoding on our Y data. Now, we can also choose which features and which target variable we want, such as do this again, but with features, transaction date, and target variable transaction amount. This will keep it more simple because we're just going to be using one feature to determine transaction amount. You can see that it's a bit simpler now of a problem set. We have to convert the date to a numerical format. Originally, the date is a date-time format in the Excel file. Of course, you can modify that in Power BI or with Python here. Then we're going to copy that code and try that in Colab, and this time it runs successfully. You can see that we get some notes, like a warning, which is not necessary to fix, but it is suggested to fix. And then we have our chart here in Colab. We have the transaction amount on the y-axis, the transaction date on the x-axis. You can see the date is in this numerical format because it has been converted. And because we had the date on the x-axis, and then we transformed it. So we had this data set transaction date, then we converted it to numerical format. We could save the original if you want to keep the dates. So in that case, you would just change this X transaction date to be something else, like encoded or numeric, rather, to be more specific. Then you would feed that data with X date numeric. You'd feed that X into there. So you'd be using this new value. But in this case, you have to be careful as you're just going to be using the X transaction date. So really what you can do is in your plot, when we do have this plot generated with X against Y, we could actually just use the data set's original transaction date instead of the X. Then if you rerun, you'll get the actual appropriate date. If you want to get that date instead of the numeric. You can see most of the data points, which are the blue circles, the blue markers, they are all along the same Y line. They're very similar. Some outliers, however, the outliers will push that best fit line up, which this red line represents the best fit line, the linear regression model equation that the machine learning algorithm created. If you remove the outliers, you'll actually get a more accurate result. So we can test that. For example, let's try this again where we have our code for our data set. Then we can inspect the data set. And you can see at the end here, we have these 3 rows. If we remove these 3 outliers, we can get more accurate results. So let's say write Python code to remove the last 3 lines, or 3 rows to be specific, from the pandas data set. This shouldn't take very much code to achieve. Let's wait for ChatGPT to generate the response of the code that we should use. Then we can try running our machine learning model again with those outliers removed, those outliers being those last 3 rows. If your agent is stalling, try refreshing the page. There could be a network error. And then paste in your prompt again and can regenerate your response. Okay, here we go. What we can do is use the ILOC property here. Index location, I'm going to use that in my data set. Let's do that in a new code cell, and then we can inspect the data set again. And you can see this time we've removed those outliers. Then we can try running the rest of the code. Okay, you'll notice here our transaction amount changes to be between 0 and 1,000 because we removed the outliers. So now we have a much smaller scale of the average transaction amounts. And then we have that predicted line. You don't have to remove the outliers, but typically it is recommended because usually outliers represent noise in your data set. However, in some cases they could be relevant and actual important samples, so it depends on the use case. That is how we can build a linear regression model for a credit card dataset and visualize our results. Let's try another model coming up in the next video. Welcome back. Previously, we built a linear regression model. What if we wanted to visualize the linear regression training to see how the slope of the line adjusts over time to our data? Well, in that case, let's copy some of our code and give it to ChatGPT, and we'll say use this code so that it knows which code we want it to work with. And let's say we want to build a GIF with Python that can show the model training, such as showing the best fit line adjust to the data. Then we're going to get a Python code snippet for creating a visual, specifically a GIF with an animation. Then we can save it to a GIF file using the Pillow library. Now for this, we will have to potentially install an extra library. Like here it's asking me to use pip install image IO for saving frames as a GIF. So let's go to our code and just use pip install image IO. Okay, then I'm going to copy this code snippet and add it to a new code cell here in Colab. Okay, here we're just going to get a type error about the date time. So let me copy that, and also we get an index error. So let me just copy all that to ChatGPT for debugging. Looks like there's a mismatch between transaction date and transaction amount, so we have to make sure we convert that to ordinal, and then we can redo. Okay, let's copy our code again and try one more time. Okay, we actually cannot convert it to ordinal. There's no such option, so we have to send that over to ChatGPT, because it's going to be a date time, so we have to do it in a different way. Okay, interesting. Now it just removes the conversion, which we can copy this new code and run. Okay, this is our result this time. We have actual versus predicted. This is the first frame of your GIF. To see the remaining frames, well, we can ask ChatGPT, how do I run the GIF in Colab? Because right now I only see the first frame. Then we can wait for a response. We can use the IPython display module. We can copy that code into a new code cell and we can run. So now you can see the GIF running. All right, so the GIF line begins at a slope and then it adjusts over time to your data. What if we wanted to play it slower? Play it slower. Well, we can ask ChatGPT to set the duration parameter. Okay, we can copy that. This is when we save the GIF. So we'll have to rerun that to save the animation with the different frames per second. Okay, so now it's set to 10. It's interesting. If it's 10 frames per second, it should be a bit slower. You could try 1 frame per second. Then rerun your code cell. Okay, now it's going to be even slower. Okay, so this time we can see our line adjusting. You notice the outliers, if you have any, or just the values that are less part of the trend, they will affect the line. And you can see the line adjust over time. You can see it starts off low, then it goes high, and then it eventually comes to a decent here location. You can also find the GIF in your files because we did save it in our code. And then you can pop that open and you can watch the GIF with your default GIF viewer, such as this one here. By default, the model begins at a random state, which means the slope or the best fit line, that red line, is going to start off in a random slope, random position. But then as the model trains on your data, the model is fitting to the data points. The goal is to draw a line to fit between the data points as closely as possible, and then that line is used as a predictor line. By visualizing these models, you can better understand how they function, because this is linear regression, but other models, they train on data completely differently. Linear regression uses a best fit line technique, but there are many other techniques for learning from data. Now, we can also do the same thing for when we had some outliers. So you'll remember before, we removed some of the outliers, right? But what we can do is bring them back in and inspect our data set. So we'll just copy that code and bring that back in. So that would be just a bit lower here. If I wanted to bring that back in. Here, when I'm generating my GIF right here, generating linear regression, fitting it. So you can bring the data set back in down here, then run all your cells. And you'll notice we have our outliers now. So when we run our GIF, you'll notice that we now have these 3 outliers which affect the results, because with the previous GIF, we actually had removed the outliers. The trend still looks similar in the data, even when we removed the outliers, because the data is not all perfectly on a line. Data is real world mimicking, so the goal is that it's going to be imperfect. It's going to be somewhat noisy, as normal data is. So this is an example of our GIF. It looks very similar to the other one, but this one here, okay, actually this is the exact one we had before. Hold on, now let's bring back in that one with the outliers. Okay, so I have these 3 outliers, transaction amount, let's go back up, 0 to 1,000. Okay, interesting. I want to make sure I have my outliers. So let me just bring in my data and make sure I have that. Okay, so I have my data set loaded. I'm going to print it out, check if it has outliers. Okay, good, it does. Then we're going to build our animation. Get these 3 up top. Interesting, these 3 up top here. So it's weird because my data should be reset. Okay, so yeah, it looks like we have our X and Y not being reset. So actually, when we create the data set, we also have to recreate the X and the Y. So make sure you do that. And we have to make sure we add that as well to our data set. Then we can rerun. Okay, so this is actually with the outliers. Okay, that makes a lot more sense. So here is our GIF with the outliers, and you can see how the outliers affect that best fit line right here. So you'll notice the best fit line still manages to keep most of the data sets on that best fit line, so the outliers don't affect it too heavily. Then you can download your new version, pop that open. There you go. Now that's the one with the outliers. And you can see how that line adjusts. Now, before we had the outliers removed, so we can more closely see the actual results, which were a bit more accurate. However, sometimes outliers are actually valuable parts of the data, so it depends on your data set. You can see at the beginning, the line of the model doesn't fit through the data points very well because the model begins completely randomly with low accuracy. But as the model goes through training, we can see that line start to trend throughout the data points, which means that the model is learning. If my model did not learn, I wouldn't see that line fit to the data points. So if you had some issue in your code, or you chose the wrong model type, then you would have less accuracy and you would see that line would not fit well with your data. For example, if you picked a completely irrelevant X or Y value, that would affect your results. You can also adjust the animation interval. For example, instead of 200, you can do 20 for your frames, and then you can inspect your GIF results. So you'll notice this time slightly different interval results. If we did 2, then we can rerun. And make sure you rerun both of your code cells. They will not run on their own, even if you update the code. Okay, so now our interval is 2. Doesn't make too much of a difference in this case. We did interval 2000. Can rerun our animation and then inspect our GIF with this 2000 interval. And you can see here it still looks relatively similar. All right, so that is how we can visualize our model training. ChatGPT is a great asset to build visuals which help you understand better whether you're solving coding problems or building models and analyzing training results. This will also help you understand the models themselves better if you can have a visual representation. Thanks for watching this video, and I'll see you in the next one. Welcome back. In this video, we're going to generate a logistic regression model with Python and ChatGPT. Join me in your ChatGPT agent. We're going to ask it to write Python code for a logistic regression model for our dataset, which is our credit card transactions dataset. Here, we're going to get some code generated using a bunch of features and a target variable. All right, then we can get to work on using some of this data for the logistic regression model, and we're going to get an accuracy score at the end. We can copy this code and bring it to Google Colab at colab.research.google.com. Paste your code, make sure you load your Excel file, drag and drop it into the files, and you can check out your results. Okay, here we're getting an error message that data type of datetime cannot be promoted to integer. And that's because we're using transaction date as one of our features, which does mean that we have to convert it to the appropriate format. So we have to convert all of our features and target values that are used. All of them have to be in a numerical format if they're not already. In this case, we try to do one-hot encoding on categorical features. However, not all of them are categorical. Fiscal year, fiscal period, merchant category, sure, those could be categorical, but transaction date is not categorical because it can be put onto a number scale. Date does have beginning and end, or an order to it, like yesterday was before today, tomorrow is after today. So I'm going to go back to ChatGPT, and you can even just paste the error message, or you could say that you need to convert the transaction date to a numerical format if you do want to use that feature. You could just remove that feature and not use it, but it could be a valuable feature. Here we can see we're converting it, okay, interesting, to a date time. Then we're extracting year, month, and day and dropping off the original. Okay, I need to redo my whole logistic regression model and just add here, take note that transaction date must be converted from date time to numerical format. All right, so this is the result we get. Taking dataset to date time as type int. Then we're going to be using that date, forming one-hot encoding on the categorical features, dropping off the first one. All right, we can try that out, copy that, paste it over into Colab. Okay, I'm still going to get unknown label type continuous, so some kind of error message which we can paste into Colab, or not Colab, but ChatGPT. So in this case, we're getting that error message because we're trying to predict something that is actually continuous. So with logistic regression, the whole point is to predict something that is categorical, usually binary, 1 or 0. So I need to convert this transaction amount into a binary variable. Now in this case, the solution that it's doing is just to completely change logistic regression to linear regression. But that's not what I want to do. I want to write the code for a logistic regression model, right? But then I want to also convert transaction amount to a binary variable. We could do above or below a threshold, like a threshold of $10,000 for the transaction amount. So here, this time we're creating this column, transaction amount binary. We can copy that code, we can paste it in. Here in Colab, we can see we're going to be checking the values. And we're going to be checking a certain threshold. If X is greater than the threshold, in this case is 0, but let's just do 10,000. Then let's run our code cell, and this time, okay, we get failure to converge error. Interesting, we can try that X to be a bit lower. We could do 1,000 instead. Or even 100, modify that threshold value. Okay, so we had to modify the threshold value because we didn't have that many transactions over 10,000. So we changed it to 100, and then we can get our accuracy of the model, 0.4. All right, interesting. So we have 40% accuracy, less than 50%, so not very good accuracy right now, considering we're just trying to guess if we're above the threshold or not. So we could try rerunning. That will always give you a different result, at least potentially, because of the inherent randomness every time you rerun. How can we improve our results? Well, we can adjust which of these features we're using for one. So in this case, we're using these 5 features to predict the transaction amount. And we're just checking if the transaction amount is greater than 100 or less than 100, less than or equal to 100. And we're using logistic regression to do the job. Then we're getting our accuracy score. So interesting results that we only got 40%. Now, what if I change it to something like 10? And my accuracy is going to be even lower, 0.2, and a failure to converge. Okay, that's a pretty poor result. What about 500? Okay, this time I get accuracy 0.8. Now, what if we removed some of our outliers? I can inspect my data set, and we know that we have outliers. I can go to data sets, paste it, and see our final 3 values. Those were outliers. We can remove outliers to see if that will improve our results. So in this case, I'm just going to go back to where we removed outliers before. So we use this iLocation property to remove those. And we can verify by pasting the name of the data set. Okay, so when you remove the outliers, you can rerun the project. This time we get much higher accuracy. But we want to pick a value that makes sense. So some of these values for the transaction amount are 100, 500, some of them are lower. Okay, so we could do instead 100, it makes a bit more sense. Accuracy 0.6, slightly better than just guessing. So that is how we can build logistic regression, and we can adjust the features that we use as well. For example, what if we only wanted to use the transaction date and the category? Well, we can remove the other ones and see how that affects our accuracy, like so. Or keep it and compare. We can also build visuals. For example, a confusion matrix. We can go to our agent at ChatGPT and ask it to build a confusion matrix for our logistic regression model results. Now, this is going to start everything from the top. So you can copy all of it, or you can just copy the end here, really. That's what we primarily need. Just make sure you import the confusion matrix if you're going to do it like that. So we have to import the confusion matrix from scikit-learn, and then we can put it to use, as long as you have all the variables needed. And here we have 3020. Now, this confusion matrix by default is a bit hard to understand, so let's generate a heat map with pyplot for the confusion matrix. Let's say generate a heat map with pyplot and seaborn as well for the confusion matrix. Then here I'm going to wait for my response. Okay, we have this code generated. And we can see here we're going to be importing a bunch of libraries, again, just doing this all again. And at the bottom, we have this confusion matrix, and we can just use this code at the very end. But for it to work, we must import seaborn. So we must make sure we add that. Then we can run our cell, just remove any text. It must be code. Must also have plot defined. So we have to import pyplot from matplotlib. And here we go, we have a confusion matrix. On the x-axis, we have predicted. On the y-axis, we have actual. And then you can compare. So for 0 versus 1. Now, what are the zeros and ones? Well, remember we had up here our binary variable. If x is greater than 100, we assign a value label of 1. Otherwise, we assign 0. So anything greater than 100 is considered a 1. Anything less than or equal to is considered a 0. You can see that the model predicted that a sample was greater than 100 2 times. And we can compare that with the actual. So we have 0 as predicted, and then 1 as actual. Then we have 1 for predicted and 1 for actual, so we got 0. And what about 0 for predicted and 0 for actual? We got 3. And then 1 for predicted, 0 for actual, we got 0. So this is how many times the model made this decision. Now we can also visualize our results with a scatter plot. So I can ask the model to generate a scatter plot for the results. This will be another way that we can visualize what we got. And again, it will give you a bunch of code here. It'll just be redoing what we already had. So if you want, you can just go with the very end here where we have our prediction. Just make sure all these values do exist. Then you can make a new code cell and you can run your scatter plot. So on the y-axis, you have predicted transaction amount, which is binary. On the x-axis, you have your transaction date. All right, and then we have our scale from 0 to 1, but it's just going to be binary, either 0 purple or 1 yellow. Now we can also then show transparency or opacity. So I'm going to say make the markers more transparent, because right now some of them are overlapping, which makes it hard to see the overlapping markers that are behind. So we'll have this scatter plot again, just modified slightly with opacity. Again, remove the text. Okay, so now you can see some of the overlap here in this result. Now on the y-axis, we currently just have the zeros. So we don't have any ones in this particular result. We can also increase the size of one of the markers, like increase the size of the actual markers, or the predicted markers, because that will again allow it just to be easier to see on the chart. What is the actual versus the predicted? So again, we can copy the code for the scatter plots right here and replace it. Okay, so now we have just different markers, makes it easier to see. The yellow circle is predicted. The X is actual, so you can see some actual values, compare them to predicted. You can see that our 1 was never actually predicted. We had a lot of predictions for 0. Some were accurate, some were not accurate. Feel free to play around with this example, change the features that you're using, add more data, experiment with the data you're using, adjust some of the parameters of the model, because all of this will affect your results. And you can even ask ChatGPT to generate some more different types of charts for you. Thanks for watching, and join me coming up in the next section. We're going to continue building out some charts.